It's starting. We are going to do, in the style of an exam question, we're going to look at what's going on between the RAM on this side and part of the content of our CPU. Not all the components of a CPU are missing. Components you must know for your GCSE are the cache, and you must be aware that there is also a control unit. At the very, very start of my program, which register is going to give a starting point? Please.
Program counter.
Program counter will contain what? We've just done it in the starter to the lesson. The program counter will contain an address of what?
First instruction.
First instruction. So which address is this? 1. Okay. So if it's an address, as we start the program, where is that address going? From the program counter, it's going to go onto the MAR, the memory address register. So the address bus is going to contact the memory, and what we want is the content of address 1. Where is that content going? At the back, please. So MDR, it's data, so it goes onto, via the data bus, it's going to go into the MDR. So at this stage, the MDR will contain what? This content. So it's going to contain LDA 8. What can we say about the content of the MDR at this instance? We are still in which part of the FDE cycle? Yes, please, at the back. So we are fetching. So if we are fetching, we know that what's coming from the memory is starting with I. Correct, instruction. So this is an instruction. So if it's an instruction, it's going to go into part of the CPU, which is not on the screen right now, called the control unit. So somewhere in the control units, this goes. So we've just fetched our instruction. The next stage of the FDE cycle is to decode it. So that's going to happen in the control unit. This is not something we need to go into detail at GCSE level, but you need to be aware of it. Please close the door. Right. We fetch the instruction. We know what's going to happen, but we need to update our registers. So the program counter has done its job. What does it need to do now? Go to the next address. So program counter will become 2. CIR should contain what? The current instruction register will contain what we've been fetching. So LDA 8, we are still doing that. And the memory address register, if we're in the execute part of a cycle, what address should this contain now? 8, absolutely. So we are now executing this instruction, so it's going to contain this address. The memory does its job. Fetch this content, which goes up here. So I need to update what the MDR contains at that part of the Fetch-Decode Execute cycle. So now it contains the number 2. And because this is LDA, load the accumulator, this also goes into the accumulator over here. And at this point, I have finished the first round of my Fetch-Decode Execute. Let's carry on until we finished this very short program. So the second instruction is to do what? Second instruction, come on. So we are going to 2. 2 is add 9. So over here, I'm going to have add 9, which also is going to appear in the current instruction register. Program counter is going to move on to 3. Memory address register is going to change to which address? 9. And as we are doing the execute, 9 goes over here. There's also a connection between the CPU and the memory to instruct the memory, we want to read from you this address. So 9 is being sent onto via the data bus into the MDR, which is going to now contain what number goes into the MDR? 7. Now something interesting happens now. 7 is going to go on this part of the ALU, and the other part is going to get that number that has been patiently waiting for us in the accumulator. All right. We are adding. So we are adding. What's going on at the output of the accumulator? Please? Yes. So 9 appears here. And as it appears here, it's also, where does, as you know, the output of the ALU is stored into the accumulator. So the accumulator is now 9. And that's the end of this instruction here. So we move on to the last one. Now that's the last instructions from our, for our program counter, because that's the end of the program. And we are going to, we need STA8. So STA8 will have been fetched. That's going to be, let's call it AND for now. So we've got STA8 over here. We are going to send the address 8. But this time, it's going to be a store operation. So if it's a store operation, something different will happen at the top here. I'm going to do it with green. So this number 9 goes into the MDR. And as it's a store operation, we'll travel from the CPU to the RAM. The RAM has been instructing to store it, so it goes into, address 8. So it goes here, and inside the memory, this becomes 9. And this is the end of our program. So you will have to answer questions in this style, looking into the contents of your registers and picking your instructions from the memory and allocating them in the correct register so that this very simple von Neumann machine will do its job. Thank you for the participation.